And for the better part of last year, it was Ben and I who were kind of presenting, and then in like the last couple of weeks, we've had members offer to present on different topics. So if you are interested in presenting, feel free to volunteer. It helps with learning, getting to know certain technologies and such. So yeah, and if you're a newcomer, welcome. And like I said, we do this every Saturday, every 2 Saturdays. And today we have Kofi, who's going to talk about do a deep dive on RAG and with LangChain. So, all right. I don't know if Ben, if you have anything to say, but otherwise, Kofi, you can take it away.
Yeah. Also, you can connect with us on Discord.
Yeah.
Okay. Yeah. All right. Thank you, Aziz. My name is Kofi Boteng. I'm a software engineer pivoting into AI engineering. And I'm keen on developing applications, especially in generations. So before I get into it, I'm going to cover some documentations, and that's the view you see now. And then look at some resources like Kaggle, where I pull some sample data. And also we're going to look at some Python code for the RAG implementation. So I'm sure you've all seen the invite. Today we want to walk through our deep dive into Retrieval Augmented Generation, which we term RAG, and then using LangChain as the library to implement a particular architecture. So normally, for this webinar or training, we're going to take a look at some techniques in NLP, natural language processing, and retrieval models for retrieving information from vector databases. I'm sure you've all seen these topics. So first of all, we're going to look at a fictitious problem statement and how you can use NLP to do data collection and process the data. Are we going to look at models, the retrieval generation and generation models, how they are integrated together. And fine-tuning, of course, we're not going to get time to get into fine-tuning because that's a whole different area of study. As well as I was hoping to get into evaluation, but I couldn't get much time to get that completed. But we're going to touch on evaluation. And deployment and monitoring is more when you want to deploy your application to production, and then monitoring the application to improve it. And that goes hand in hand with continuous improvement. Ethics is a big area right now with LLMs. So as you build in your LLMs, you have to think about the bias in your data or your algorithms. That way you do not negatively impact users. All right. The documentation is translated in French as well. So we have the English version and then the French translation. So for the problem statement, can you guys see the text well? Is it large enough?
Yeah.
Okay. All right. So for this problem that we're going to look at today, I imagine a healthcare system where they've hired an AI engineer to implement an LLM in the existing corporate infrastructure. So the engineer is to leverage existing hospital data, such as the patient's data, the payers, the location of hospitals, the physicians, and what have you. So normally, this kind of data today is sitting in relational databases or external data stores where which the engineer has to have a higher view of where all these sources of data is coming from. All right, so as the engineer, the question is, are you going to leverage existing models, or are you going to build models from scratch? Thinking about how sensitive hospital data is in terms of data privacy and all that, it may be advisable, a good advice for you to start or build your own model, or find an existing model that is built for the healthcare domain to pre-train that model for this specific hospital. If you have any questions, you can jump in and ask your question or text your question in the chat. So once you know where the data is coming from, you have to do an initial analysis. There may be a team working on that. If you are building from scratch, if you're building a new NLP model, you have to think about what form is this data in, right? Some of these data in the relational databases may not have, some of the roles may not have values in certain, may not have data in some of the fields in the database. So in that case, what do you do, right? So you first have to normalize all these data sources in order to remove noises from this data, and in order to be able to build a good model. So some of the techniques to think about is tokenization. What's your tokenization technique in getting that done? And then here we have information about what tokenization is. I'm not going to go into details, but yeah, it's just a technique to break down sentences into words, because these NLP algorithms understands or work on words instead of sentences or paragraphs. Another thing you have to think about is also probably lowercasing all the data. So for example, if you take the word word with the capital W in front, this word is different from all small cases or all upper cases as far as the NLP algorithm is concerned. So that a good technique is to lowercase everything. There's also removal of stop words, which has not no meaning, but minimal meaning to the sentence. Words like the, is, and, etc. And there's also the stemming and lemmatization of words, meaning, for example, when you take running, right, runs and run, these three words are all rooted from the word run, right? So in order to handle this noise, you eliminate all these words and use the root word. So overall, these are techniques that goes into building an NLP algorithm from scratch. But if you are choosing a model, an existing model, then you don't have to worry about these techniques. Any questions? All right. So we're moving forward. So in our scenario here, there are some considerations that needs to happen. Every model, LLM model, or even the one that you build, has specific prompt inputs, right? So if you're choosing an existing one, you have to know what are the prompts or the prompt format that that model will take. If you build in from scratch, then you have to know how to design your prompt. Also, there are models. Models depend on data formats, right? Are you using JSON on XML? Example, the Anthropic model works best on XML, while the GPTs works best on JSON. So now at this point, we get into retrieval model. So there are different types of retrieval models based on task. Retrieval models that basically takes an input and then embeds that input and then do a similarity search on a vector database and retrieve the data that is close to that input, right? That's similar to that input. Today, what we will be using is the vector space models. Basically, it retrieves documents or queries from a vector space. And as I mentioned, it does similarity search on the database. There are other types like neural retrieval models, and then these models can also be trained or fine-tuned on the company's data set. That way, the model knows the nuances in the hospital data. Once the data is retrieved, that retrieved data needs to be sent to the LLM, right, the generation model. So you also have to think about how to select a good generation model for the use case, or even if you have to design one from scratch, then you have to employ all the ML techniques and using neural networks to build one from scratch. Then the model, of course, needs to be trained on the hospital's data. So now we have the retrieval model, we have the generation model. These models needs to be integrated to create the application or the chatbot. So this is where the integration comes in. Today, what we will be looking at is the sequential approach. Basically, there's retrieval, the retrieval does some templating, the program does some templating, sends that template, feeds that template into the LLM, and then the LLM generates based on the text, the input text, and generates the output to the user. As I mentioned, fine-tuning, we're not going to touch on fine-tuning today, but you have to be aware that the retrieval model needs to be fine-tuned, the generation model needs to be fine-tuned, and then also you have to think about evaluation. Evaluation, basically, as you retrieving, when you embed and you store information in the vector store, the vector database, and now you query or retrieve data from the vector store, is that query results, how similar or how relevant is that query results to the question that was asked, right? So there are metrics, some metric standards that are already in place. One is called Blue, and there's a Rouge metrics that you have to employ in your RAG to really handle efficiency. Also, there's human evaluation, right? So humans can physically review generation results to users' queries and make sure the results are meet the quality standards or the requirements of the organization. One other good library that is being used recently is the True Error. I'm looking into using a True Error, but I have to spend more time on it. So that may be a different training that we may do in future around evaluation. Of course, once the RAG architecture is built, you have to deploy to production, monitor the performance, and then continuously improve based on user feedback, and even how the failures that happens, right? The failures happen in production. So once you have to improve on that. Ethics, as I mentioned, you have to be mindful of these terms here, but bias in your data. If you have bias in your data, if you're creating or even if you fine tune a model, then you're introducing that bias in that model, right? Privacy is also big, especially in the healthcare industry. You have to think about who has access to which data, right? So in an organization, we have employees, we have managers, we have administrators, we have top leadership, as well as users to the system. So who should have access to which data? So it's not just like you just embedding data into the vector store and then integrating it with the model to generate information. But you have to really think about if it's an external user using the chatbot, are they able to query financial information about a hospital, right?
Yeah, so I think
Kofi, there's a question. Well,
okay.
Yeah, Akuba, go ahead.
Kofi, I'm sorry. Can you re-explain again RAG? I mean, what is the purpose of RAG? You probably said at the beginning, but I think I'm lost now.
Okay. We're actually going to get into it, but basically, you know about what LLM is, large language model.
Yes.
So initially, you just you query the model, and then the model responds to your query. So now this model have been pre-trained on a certain data set. But let's say for a typical company, let's say, a month's time, there's new data company. The model has not been trained on, or have not seen that new data. So in order to incorporate that new data into the whole system, the whole app, you have to build your architecture in a way to, when the questions are asked, to leverage the new data, to combine that new data with the question that's being asked, and then feeding that into the LLM for response. So RAG is just an approach to bring in new data in prompting the LLM to produce a result.
Okay. Okay.
Is that clear, or you still need?
I mean, give me an idea, and since you say you're going to go further, I'll see.
Yeah, once we get to the architecture, I think it's going to be clearer.
Okay, thank you.
All right.
I have a question, Kofi.
Sure.
Yeah, when you talk about ethical, what are ways, I guess, one can, do you know any of ways, we can do to be, I guess, less biased, especially in this context?
In the hospital context,
or any context, really, like.
Right. There are tools out there where you can I haven't gone into that area yet, but there are tools out there where you can run your data through for it to show you metrics, whether there's there's bias in your data. I haven't really, as I said, looked into that area yet, but
so we have to just make sure that there is bias, and then we have to kind of like ensure that we take that into consideration with anything we do with the data, basically.
Yeah, there's one picture that was circulating a couple of months back. I think there was a question being asked, and then the LLM produced a picture of this black person, because at that era, even that black person wasn't how should I put it? Basically the question wasn't about that, but the LLM generated something else. You can term it as a hallucination, but again, somebody else can read that as being biased, right?
Right.
So these are some of the nuances that needs to be looked at and discussed, and then finding ways to reduce such occurrences.
Okay. Thank you.
All right. So, I mean, we in an implementation environment, definitely there should be documentation and ongoing maintenance. So the next section is Naïve Retrieval Augmented Generation. So Naïve RAG is just a straightforward implementation of the RAG approach, right? The RAG framework. Basically, you have data that is being ingested into a vector database, and then you have the integration with the LLM, and then you can query the application. In this setup, there's no guardrails around it, right? There's data privacy issues with this kind of setup. Very straightforward setup. There's no optimization in place. There's probably less evaluation done on the system. So in such a setup, that's why the term naive. There may be, of course, hallucinations in place, because this is not really a solid production ready setup. Mainly that Naïve RAG is prototyping. Like if you want to do a demo like what we're doing today, it's quick to set up. Of course, if you're building a RAG, any type of kind of RAG, Naïve or advanced, you have to have the retrieval component, right? As we talked about, you need to choose a retrieval model or build one from scratch and train it. You have to have a generation component as well. There's the actual model that does the inference. We talked about that, and you have to integrate the components. So we've seen that. We've seen evaluation and optimization. So some of the challenges with the Naïve RAG is inaccurate retrieval, right? The retrieval may be inaccurate based on because it's not the RAG, the setup is not optimized. So you see inaccuracies in your retrieval. There will be hallucinations, and even context. There may be context overflow, right? That is where, for example, LLMs will have, I think the GPTs initially had like 2048 context window. So if those things are not handled, then you overflow the context. Is that a question?
Applications of RAG. Well, how can it be used?
How can RAG be used?
How is it used?
Basically, as I mentioned earlier, it's a way for you to introduce new data or relevant data that goes into your LLM. So in text, in different tasks, right? If you do question and answer chat, text in summarization, in all those scenarios, you can use RAG.
Can you give an example?
We're going to take a look at an example. All right. So we're going to get into one example very soon. So give me a few minutes. So the next one, so that begs the question, that moves us into advanced RAG system, right? This system is built for production, and it's got all the optimizations in place, all the improvements that Naïve implementation doesn't have. The system has been evaluated based on several metrics and even human inspection and all that. So with advanced RAG, you have to really choose a good retrieval model, as well as a good generation model. Again, the question is based on sensitivity of data. Are you going to use the public APIs, or are you going to use open source Hugging Face transformers? So these are all the things that needs to be discussed initially with the business, with the company, to find out which direction to take. So once these components are selected, then you do the integration, right? It's the same thing we looked at before, but this time we're looking at advanced RAG. Of course, the evaluation process will be done on the retrieval end, and also the inference from the output from the LLM itself. How relevant is the output to the question that is being asked? Of course, you have to think about scalability, right? In any system, is that system that you've built able to handle? All right. So are you doing this in-house, or are you doing this on the cloud? So now we get into the architecture. All right, can you all see?
Yes.
Okay. All right, so this is the flow that I created to implement the RAG that we've been talking about. So hopefully this will share more light into what we went through earlier. So before anything, as I mentioned, you have to think about data. So when you look down here, we have documents, PDF, CSV, URLs, SQL bases. So as an AI engineer or generative AI engineer, you have to determine all the sources of data, right? So assuming that we're not building the models from scratch, we're just choosing the right components to use. So in that case, this document area may be an AWS S3 bucket, right? So in that bucket, there may be large PDF documents, multiple documents, multiple CSVs. There may be URLs for web scraping. There may be SQL databases all scattered around in your organization. So how do you pull all these information into your RAG? Okay, this is the RAG architecture. So a lot of work needs to be done or goes into implementing the RAG. So once you have the data, so at this point, I think I can show the data that we will be using for the hospital application. So I pulled a data source from Kaggle, right? So these are healthcare data sets that I downloaded. It's got about 10,000 rows in the file. So we can take a look at the file. This is the file. So it's got the patient's name, the age, the gender, blood type, medical condition, doctor's information, the hospital, and the billing information, and the room, whether it's emergency or urgent care, the medication that they are on, and then the test results. All right, so this data has already been created, and you can find that on Kaggle. So normally for a traditional application, you take this data and then you create different tables in your relational database to query, to this data into those tables and then you use for query results. All right, but in our case here, we're going to use this differently. So going back to the architecture, so here we have our document, and then we have to do some data manipulations here. So all these things I'm going to show in the Python code as well. So there's some data manipulations that needs to be done, considered. And then that data is fed through the embedding model. So the embedding model will basically the data will be tokenized, right? Once you put through the embedding model, it's not tokenized, it's chunked, will be chunked into different vectors, right? So it takes each role and forms a document for that role. So for that 10,000 lines of rows of data here, each one of them will be just one document with some metadata information for it. So that information is in the embedding changes these words here, right? These names changes that into numbers, zeros and ones, and that is the vector, the data, the embedding data that is stored in the vector store or vector database. In our case, we will be using the phase. It's a memory, Python memory. It's a Python library used for storing vectors in memory. So now we have the data ingested, sitting in the vector store. And what happens is when a user sends a query, right? For example, the user wants to know how many patients have cancer condition, right? So as you see this column here, column E, medical condition, we have cancer, we have obesity, we have asthma. So once that question comes in, your application will embed that question and sends it to, passes it through, you feed it through the embedding model, and then the embedding model embeds that, converts those the question into zeros and ones, and then it does a similarity search. How similar is this question to the information in the vector store? So it then retrieves the output. So there may be, let's say, based on our data, we have 10,000 roles. So let's say when you ask for how many people has cancer condition, medical condition, there may be, let's say, 500 roles of data that's returned. So that data is the context, right? Is the context. So on this section, the prompt templating takes the input query and then adds the context to it, right? So we have query plus context that goes into the LLM model. So the LLM model takes the query and the context, and then based on these two information, produces a response, and that response is sent back to the user. All right. So so this may be, without looking at evaluation and optimization and all that. And Naïve RAG looks just like this, right? So you do your vectorization, you embed your data and store in the vector store, and then you query that. And then you send the results to the LLM for response. So as we've seen from the text, that's how the Naïve RAG behaves. But on top of that, you have to take a look at the advanced RAG. You have to take a look or think about data privacy, right? Hospital data is highly sensitive. Personal identification information, you don't want that to be out there in the public. So these are all the considerations that needs to happen, and then guardrails built around that. The evaluation, for example, how for this retrieval, the retrieval results, how similar in metrics terms, how relevant is this information from the question, right? So there are tools like the true error blue that can tell you that based on the 500 roles that came out, let's say 10 of those roles, for example, 10 of those roles closely relevant to your query. These are the things that needs to be thought about. So evaluation definitely needs to happen in the retrieval and also in the response from the LLM, on top of building security around your data. Any questions there? Is it clear?
I think Akuba had a question, right?
Okay.
I had a question, but because I think he tried to simplify. That's why I retrieved my question, because I was about to say, first of all, the data, the file that we use, you say Excel, PDF, and I was about to ask two questions. The first one is, could we have pictures and videos in the data?
Yes, it's all about your use case, right? In this case, we only focusing on a hospital data. But
yeah, but the hospital, sometimes you do the scanning, MRI, I don't even know, image, things like that, and it's in the records of the patient.
Right. So there's image processing models that there are models that handles image.
Yeah.
This is just text based, right? So we have text to image, we have image to image, and then you get into the vision aspect of it. So yes, you can introduce more complications into your RAG.
Okay. I see.
It's not just text based. It's image and other modalities.
And now my quick second question. I know it's simplified because you took the data from Kaggle. It's already organized. It's already, I would say, data set. But in reality, is it the I don't know, the I don't know, data scientist, I don't know, AI guy, AI engineer that will organize the file, or the hospital in that case will have to do a preliminary work before the AI engineer start processing them? I don't know if that makes sense.
Yeah, you do. So that's the reason why I actually started with the NLP aspect of it. When you go back here, all the way up. So here, the data processing. So that's what I was saying, that
That's right.
before getting to this input that we grabbed from Kaggle, we all know that for a typical hospital, data will be everywhere, right?
Mm-hmm.
Excuse me. So this is where, you know, it's not just one person, right? If the models are being built from scratch, then you need the AI engineer, you need the machine learning, the data scientists, you know, all these
Yeah.
folks working together
Mm-hmm.
to normalize the data,
Okay.
right? And these normalized data, if we're building a new model, to use that normalized data to, you know, build a model. So once that model is built, the data scientist also helps in, you know, getting the data to. So this data may be coming from multiple sources, right? It's not one table. So you have to really know about where all the data sources are and what, based on use case, this application that we're building with a specific requirement, what are the data fields needed from all these different sources? So you pull all those things together to come up with this, and it shouldn't be, it may not be in Excel, right? It may be in PDF, or it can be from tables. So if it's from tables, you know, query all this data together. You want to get the data in a form where when you get to this section, the embedding section, you have things in place, not all scattered, right? So preliminary work, huge amount of time will have to be spent here formulating the data. And that's just to get to, for example, this set of data. But before that, there may be even different tags to, if we're creating new models, to, you know, consider the tokenizations and, you know, all those things that the ML resources do.
Okay. Can I ask one more question?
So
That's me, okay? I still get confused between data set, data frame, and tables. Can you clarify the, I don't know, the differences, you know?
okay, so I'll take a shot at probably Aziz and Ben will help, because Ben, I think Ben is a data scientist.
Ben confused me. That's why I'm asking you.
So
We'll try.
yeah, so data set is just a set of data. For example, when you look at this section here, we have the PDF, CSV. So these are sets of data.
So
right?
they are not on the table format necessarily.
They can be in table, the relational, you know, tables also. So it is just a term to say that these are the set of data being considered in this application.
Okay.
Ben, correct me if I'm speaking wrongly.
Yeah.
Yeah, I mean, that's how I'm thinking about it as well. Data set is just a collection of data that you have available.
Right.
Yeah.
So data frame, again, I'm not a data scientist, is when you put this data, you know, there are you know, Python tools. When you read this data into those tools, and then you can display the data in a tabular format. Ben, is that correct?
Yes. So I think both tables and data sets, you can think of it as, I mean, not data set, both tables and data.
Data frame.
Yes, you can think of them as basically what the data set is, like one item of the data set, its representation in memory, whether it's on disk or in the memory of your program. So usually tables, when we talk about tables, we are thinking of two-dimensional data, like in a SQL database, for example, right? But for data frame, it's not limited to just two dimensions. It can have an arbitrary number of dimensions because it's a vector representation in memory. So,
Okay.
yeah.
Thank you. That's it.
You're welcome. Any more questions?
Yeah. And also there's a lot of overlap into these concepts. Like I know that, for example, if you use Python and pandas, I know you can operate with an arbitrary number of dimensions for a data frame using pandas, but you can very well also work in 2 dimensions or even interact with a SQL database. So, yeah.
Okay. So any questions on this architecture? Or we're moving into LangChain.
Yeah, I think you can. There's nothing in the chat, no question in the chat. So.
Okay. Well, let's see where we are. All right. So now, we've seen the architecture, and then we are at a point where, how do we build this? There are a lot of open source. I shouldn't even say open source. There are a lot of tools out there that you may leverage to build the app. There's I think Llama Index, and then there's LangChain itself. And I'm sure you can custom build this using Python and other frameworks. But in our case here, we're going to take a look at LangChain. So this site for LangChain, basically it's a framework that helps you to build applications using large language models. There are different components that comes with it. So LangChain, one of the components is a model, right? It's got interfaces to almost a lot of models out there, right? The Hugging Face models, ChatGPT, the meta models and all that. So so these are tools that you can leverage. LangChain has provided to leverage to build applications based on LLMs. So there are there's a way tools for prompts, setting out your prompts into the LLM. There are prompt templates. So that's that. As two types. There's the LLM, the LLMs, the text. So the LLMs are generally for text generation, and then with this LLM, they've modified the LLMs to behave as chat models. So you can think of this as, there's a chat models, tools, and then there's LLMs. And the output process are used to format the outputs from the LLM when the LLM produces the results, normally it's not in a user-friendly or readable view. So you use the output process to parse the output to get it into a readable format. And then LangChain also has the retrieval, right? So for all those documents, the PDFs, the CSVs, the web scraping, and then interfacing with SQL databases, MySQL. I know they have interface for MySQL. I'm not sure about MongoDB, but there may be. So they have these document loaders, right? As you can see, they have all these document loaders. These are ways of loading the your CSV file, and then create it. So when we looked at this, we said that during the data manipulation, so this is where you can use LangChain to read the CSV file, our hospital file, and then it chunks it into, for each role, it creates a document for each role, basically. So the document loaders are used to do that. All right. And then text splitters. So for CSV, you do not need text splitter, but there are text splitters for PDFs and other document forms. And then we have the embedding models. So as a retriever, so this is the embedding model here. You can use this to code your embedding model, and then they have vector stores. The vector stores here, as mentioned, I'm using, let's see, vector stores, what do they have? Yeah, so they have the chroma, phase, and lines, but we are using phase today. And it gives you a code snippet how you can store data and retrieve it. So that's the embedding aspect. And then the retrieval models. There are retrieval models today. I'm using one from OpenAI. I tried to use an open source, but the delay was too much. So I decided to go ahead with the OpenAI retrieval models here. These topics I wanted to cover as well, but again, I didn't have much time because there are concepts like tools and agents and chains. But we're going to see chains. Definitely what we're going to take a look at today is chains. But on top of chains, you can have agents, right? Agents can decide which tool to use to accomplish certain task. All right, but we're going to take a look at chains. And then there's integrations to other third-party providers. What else? Any questions here?
Yeah, just a basic, maybe comment if you know. Is LangChain like you widely used? Like, is it a popular tool? I'm actually just curious.
Oh yeah, yeah, definitely. So I believe in the industry right now, it's LangChain and Llama Index.
Okay.
not sure about competition who is leading what, but LangChain is widely used. Yes.
Okay. So it's worth learning, is what you're saying.
Oh, definitely. Yeah.
All right.
Yeah, I think one thing that's very nice with LangChain is that coming back to the architectural diagram from that Kofi showed earlier, like all of those arrows are abstracted away in LangChain. You know, so that when we land on specific blocks in the diagram, we get to choose like replacements as needed. You know, so for example, picking one vector database versus another choice through LangChain, there's not much you know, like
Change.
it's not difficult to do because it's built as an abstraction.
Yeah.
You know,
So
versus doing it manually.
So what you're saying is that using LangChain, you're able to like build a lot of things a la carte, basically, right?
Yes.
Okay. All right.
It's more flexible.
All right. Okay.
That is correct. And what Bernard said is it's just few code of lines of code. You know, maybe 2, 3 lines of code to just do that replacement. All right. So there's some architectural diagrams on here, but I don't want to go into that. There are no further questions. Then we get into the code. All right. So based from what we've seen, you know, let's just focus on the architectural diagram here. And this is what we're gonna build. So in doing that, of course, there are many ways of doing it, but for now, what we have as a prototype is that I have the CSV file in the data folder, right? So it's sitting there here. And then I built a utility. The evaluation, I haven't gotten there yet, so it's blank in here, but this utility is the document for this specific use case, the CSV. Basically, we imported 2 libraries, the CSV loader, which is from LangChain, and then the vector database, which is phase that we're going to use. This model takes the embeddings. The embedding is a model, right? It takes the embedding model. So what this method does is it first loads the CSV file. So this is the healthcare data set. It loads the file into memory. So loader dots. So this pointing, this an instantiation of the CSV loader, and then it loads the file into this data object. And now for phase, for the vector store, all you do is you say phase.from documents. You pass in the loaded document and then the embedding model. So when you do that, this line will basically create a database. Again, this is in memory, so I could have used like Chroma or other products that will persist the data, right? And then the function returns the database. Close this. So in the main program, we are importing a lot more libraries, right? As you can see, we are using the OpenAI embeddings. So this OpenAI embeddings is the object for object to handle this aspect of the in the RAG, this handling this aspect of it. And then we have the chat OpenAI. So this is actually the LLM over here. And then we have the output parser, as we saw on the LangChain's website. They have output parsers, but we're using the string output parser. And then we imported all the prompt templates, right, for our chat functionality. We have the prompt template, the system message, the human, and then chat. These are runnable pass-through. And then here I'm importing my custom model under the utilities. So this is importing this into the main program. So here again, if you're using OpenAI, you have to have your API keys. So I have my API key stored in the environment as environment variable, and I'm loading that in here. So here I instantiate the embedding model using that OpenAI embeddings that we imported. This is the model. We're using the text model embedding 3, the small version. You have the small and large. I'm using the small version here. And then passing in the key also. The next line, I'm importing, I'm calling the load health data. This is to create my database. Again, that procedure here returns the DB. So I'm returning the DB in the name. That way I can, so at this point, when you call this line, the data has already been loaded, right? Because it's looking at where the file is stored and then loading the data in the DB. So at this point, we have our vector database.
So when it's loaded, is it just a matter of loading it, or is it you have to do anything else? The vector database like takes care of everything, like basically converting everything to the vector space. That's
what is happening. So that's the abstraction that Ben mentioned. So on this line here is doing everything. It's looking at this data, which is being loaded in this variable, and then using the embedding model to do the conversion into vectors, and then returning the database. So this database now contains the 10,000 lines of rows of data from our Excel file.
But not in this format, right? Just to clarify for folks, it's not in the Excel format anymore. It's now become in a vector database format, like a
it's more of a float number. So you see negative float numbers with a lot of precisions, like large precisions. So when you print in here, you can query. I think we can print. Then we can print this. When you print this, it gives you the vectors.
Okay.
And these are zeros and ones and float numbers.
Okay.
It's not something readable. So.
Okay. Okay. Thank you.
Sure.
Yeah, actually, I just shared the link. We can probably, like, whoever is interested can take a look and see what the vector looks like with all the numbers that Kofi mentioned.
Thank you, Ben. All right. So now we have our DB, right? We are here, the vector store. We have that question? No.
I think Northwick, you have a question, Northwick?
Yeah, are there any, of any programmers who can do this as well as AI, machine learning, and data programming?
Are you asking if we know anyone that can do the programming?
Yeah, send a message in the chat.
Yeah. Do we want to wait for this at the end of the talk? Maybe you can ask then.
Okay.
Yeah, let's wait at the end of the talk. But if you have any questions regarding the talk itself, go ahead. But for announcements, we want to wait until the end if possible. All right. Okay. Go ahead, Kofi.
All right. So at this point, we have our huge data ingested or embedded into our vector store. Now we move ahead and then instantiate our chat model.
Can I ask you a question?
Sure.
Sorry to. What do you mean exactly by embedded?
Okay. So embedding is basically if you take a word, you convert that into zeros and ones that must that the model understands, right? Computers do not for example, behind this thing, when you really look at how these the word load is represented or load health data is represented on disk is zeros and ones. So basically, this model is able to words and then convert it into machine numbers and then stores that data as vectors in the database. Ben, do you want to add to that, or Aziz?
I think I have another. Maybe this is me. So when it's embedded is in terms of 0, 1, 0, 1. Isn't that the I don't know, the app or the computer can confuse? Let's say if run R is 0, can anything else be 0 also? And then the machine can be confused. I don't know if that makes sense. Because you break it down things, and then you convert in terms of 0 and 1 so that the machine will be able to understand, right?
So
let's say the 0 will represent what? It can represent many things, right? I don't know if I make sense.
So there's when you learn about the transformer architecture, it also talks about attention mechanism, right? So it's not as simply as just converting it to zeros and ones, but for example, when we're talking about models, it knows the English dictionary, right? It knows your model knows everything about the English dictionary. Now it knows about the meanings. For example, if you take run, it knows the meaning of run is and all the other words that
running, ran.
Yeah, surrounds run. So, and then there's some probability calculations that goes on to rank all these things. It's complex. I'm not a AI engineer yet, but I believe Ben can give you more.
No, that's why I don't think I need to know that, right? I don't need to know.
No,
I think
to put it simply, when the embedding is done, it's not at the individual digits in the vector. You know, 0 cannot stand for one thing and then another. It's more like the whole vector that represents something. You know, and then based on on the type of like processing that's being done, you know, the vector size will be chosen. Some will be like 1500 like items long. Some will be 256, and it's the combination of those exact numbers in the whole vector that will represent something.
Something is going to have meaning. Okay, thank you.
So each word will have its own vector with different float numbers representing different things for it. Right. Okay. Any question? Further questions? Okay. So I think we are here. Yeah, so we've stored the data here as form of vectors. That's my program. All right. So here, line 29, we create the chat model, and it says the LLM. And we're using the GPT 3.5 Turbo setting. And this specific example, the temperature doesn't mean anything. So it's set at 0, and then I pass in my OpenAI API key. So this instantiates the model, and then in terms of similarity, so we are here in a question, and then the model will do a similarity search and return results. So that's what is going on here. So this is the question: list out the patients who are on Lipitor medication. So the embeddings, remember we said we have a model called embedding here. Actually this one. So it's the same model anyways. So the embedding embeds the query, this query strings is going to create another vector here. And then that vector is used to do the similarity search, right? And I'm telling it to return the top 10 results. So this query may return over 1,000 roles, but I just need the top 10. So these top 10, dogs will be in this variable here. And here, what I'm doing is I'm just printing out what is being returned from in the docs. I'm just printing that out. And then I'm going back. I'm taking the DB, all right? So we have the DB. I'm going back to actually do, so this is to just, as a human, to see what is being returned from this. So this can be an evaluation aspect of it, right? To view different return documents and then compare that to the question or something like that. So there's something that can be evaluated that way. And then I'm going back to take the database, right, the DB, and doing a creating it as a retriever, right? And I want to return 10 as well. Now, so this is where the templating comes in. So here, so we've set the retriever, we're setting it up, and then we're going to use LangChain to get a question and pass the question to the retriever, and then the retriever will return a result, and those results are passed through the template, and then we form the query and context into the LLM. So that's what is going to happen next. So as you can see up here, we imported different templates. So the system template here, what it does is you can instruct the LLM to behave a certain way. So down the code, we're going to format that template. As much as the human prompt template, we're going to format that as well. Where's that? So the system template, we saying that, you know, your job is to use the hospital data provided to answer questions regarding, these are all the columns from the Excel, right? Be as detailed as possible. If you do not know the answer, don't force it, basically. All right, but use the context. So the context is the output of the retrieval results from the vector database. That's the context. So just use the context and the LLM to produce results. So within that template, we are passing in the context, right? And then, so that's just a string, what we just look at. So we're using that string here as a template, and the input to that template is the context. So we have that set up. And now we get into the human, the question itself, right? What the user is asking. So that's also set up using this wrapper. And now the messages just have those two templates above that is set up. And then review prompt template. This is the two, so this is where we are here. We are joining the query and the context that go that, so the chat prompt template. So once we have all this, then most of the work is done, right? So here you use LangChain to chain all the different things that has been built up there. So here we're passing the context. We're passing the context a hospital retriever, and hospital retriever is our I think it's our embedded model here. Yeah, a hospital retriever is our embedded model. So the embedded model, when I flip back here, this is the retriever, right? So in the retriever, we're passing down here, we're going to invoke. So let me go down here and a second, just it down. So here, this line, when you invoke on the chain, right? This is the chain. You invoke the chain, you're passing the, and that question is inputted into the retriever to do the retrieval and then return the context. And also the same question is passed through into this question here. So once this is done, it's piped, it's changed to the template. And we have the context, we have the question. So we pass it into the templates, which we've already built. You've seen it up here. All right. And then once the template is, the template has these two variables, information coming in, it's being passed or chained to the chat model. So that's the LLM here. And then the LLM responds, and the response is passed through the output parser to put it in a readable format. So this is the chain aspect of LangChain. Is it clear here?
So just so I understand, like it's basically for the lack of a better word, chaining the calls, right? So it's doing the step 84 first, line 84, I mean, and then doing the review prompt template, then the model, and then doing the output. So basically similar to like a I don't know, like a pipeline in a way.
A pipeline, a workflow,
Yeah.
can have different terms. Exactly. So
Okay.
that's what it's doing here.
Okay.
Yeah, and quick. I want to make a quick comment. That looks almost like the like piping the outputs from one command to another, like using Linux. Because just reading the codes, if I understand well, the initial data is on line 84 that has the context and the question, right? And then this one gets passed to the review prompt template, which is, I'm assuming, a function. And then after that function runs, the output of that gets passed as an input to the chat model on 86. It does some processing, and then the output of that goes to the string output parser. Is that correct?
Exactly.
Yeah. Okay.
Yeah.
That's
That's why initially I used pipe, because I've done piping in Linux before, back in the day. So it's similar concept.
Yeah, I never knew that Python had this syntax before. I've seen it in other languages, but I guess I've never seen it in Python. That's pretty neat.
Yeah, I've only seen it in this context, in the LangChain context too. I've never seen it in any other context either.
Yeah. I think it's the abstraction that LangChain and Llama X are building.
Mm-hmm.
So this is on top of the, if you will, the core Python language.
Okay.
All right. So now we've done all the hard work, the setup, the integration, if you will. And then I have 3 examples here. First, I want to list out some of the patients who are on Lipitor medication. Is the same question that we used. We asked the embedding model, but this time we're asking the whole chain. We're sending it, we're invoking it on the whole chain. And then there's another question, list out some of the hospitals with abnormal test results. And then the third question is list all the payers with the highest billing amounts. I need to change this text here. Okay. All right, so I'll go ahead and run this app. So this gonna connect to ChatGPT API, then do its thing. Even ChatGPT is taking this long. I was trying to do this with a local model hosted locally. It was taking some time.
It's Saturday. Probably great. That's taking unusually long for sure.
It's because of the database, right? We're using phase in memory.
Okay.
That's why it's slow. But if I use like Chroma to, or even store the DB on disk, that would have been faster.
Okay.
Because it's loading all the 10,000 rows in memory now.
Got it.
I'll probably change it into Chroma database and see how fast that happens. Let's see what is going on here now. Not this one. The API instead. Should be done by now. No? There you go. All right. So basically, this is the first 10. Just looping through the docs. The return, the retrieved results from the retrieval, right? So it returning the first 10. But where we really ask the question is patients who have who are on Lipitor. So as you can see, we can do some validation here. Let me just take this one. So we're looking at David. Let's see whether David is really on Lipitor. There you go. So let's look at the medical education. Of course, David is on Lipitor. So you can do that kind of validation. You can try Brittany as well. It should give us similar results. Yeah. So Brittany is also Lipitor. So our assumption is that all these 10 are on Lipitor medication. And then our second question was abnormal test results. What's the question again? So list out hospitals. So let's look for hospitals with abnormal test results. Let's say Johnson Group. Hospitals. All right, so Johnson Group. Test results is the last column. So Johnson Group definitely has abnormal test results and other test results as well, but it pulled it because of the rows with the abnormality. And then the last question is list the providers with the highest billing amount. So highest billing amount that we can just sort the billing. I think it's already sorted. Let's make sure. All right. So the highest billing here, as you can see, is almost $10,000. And the hospitals are United Health, Medicare, Aetna, Blue Cross, Cigna. And exactly that's what we have here. All right. So the reason why you're going to use RAG is, let's say, it's wrong. It's a wrong. Let's say, let me see a hospital that's not here. Okay, it's mainly these hospitals. But let's say a new hospital comes in play, and then the billing amount is, let's say, $15,000. At this point, the LLM, even if you fine tune the LLM on this data initially, the LLM will not have that new information. So the way you can incorporate new information into your application is to implement RAG, the RAG in your app, because the RAG can, because this area here, this section here, the data injection should be ongoing, right? So this should be always be feeding the vector store. So as soon as new information comes in, then the retriever can see that, and then the templates, the input template will be formed and then sent to the LLM. So the LLM will not see that data here, the new data coming in, but during setting up RAG will help bring in that data for inference. So that is all that I have for today. Is there any questions?
Yes, I have a question, or maybe, yeah, a question. Maybe can you restate what are the limitations with of this approach with RAG?
Oh, there are a lot of limitations, but these limitations needs to be minimized or even resolved, right? There's data privacy issues. So again, with all this information from the hospital in here, when you're talking about medication conditions and and then you know, all this, yeah, meditation conditions, blood types and all that, those are all private information that hospitals shouldn't share to the public, right? So when you setting this up, how do you handle that? So that's what I was saying initially, that in the organization at the hospital, there are different types of users of the system. So how do we build security in place that way? If this chatbot is on the portal, whoever whoever queries the interfaces with the chatbot, what data should they see, right? So all these things needs to be handled before it's implemented. And then there's the SQL injection thing is, it's not just with RAG, it's with all applications. But hallucination, definitely this resolves or minimizes hallucination. But and then what else? The context window. So this templating, the model that you're using, what is the context window size? Let's say, for example, just for talking's sake, let's say the window size is 2,000 characters, but as big as your system is, even this 10,000 rows of data, a query may result in 5,000 rows coming out. So and then on top of that, you add a query. So you're going to overflow the window. How do you handle that? Do you chunk this data and query the LLM in sequential manner to get different results, and then combine that results and push it back into the LLM for a final response? So these are different things that needs to be looked at to really create a high performant RAG or advanced RAG.
Yeah, that's very interesting actually. I've been doing some reading like in the last couple of weeks. That made me think about RAGs like in a slightly different way. So I mean, my current thinking is that like there are obvious limitations with RAG. Like another one would be like the step that you did at the end to look into the Excel table to verify that what the RAG gave as an answer was actually correct, right? So from what I was reading this week, I was reading more about agents and function calling. Function calling that LangChain supports. I think I shared the link in the chat. So from what I got from it is that instead of having to do a lot of processing ahead of time to store information into a vector database, and then have the LLM together with a library like LangChain, like enhance the context to figure out what the answer is. What I found out is that using agents and function calling, they rely more on the existing systems. So for example, that data set will be like the responsibility of one department in the company, and they probably have an API to serve some of the data, right? It's just that the API itself is dumb. It doesn't do any reasoning, right? So then what they will prompt the LLM using the agent and function calling technique, the LLM will understand that at some point it needs to make use of that API. So if we were asking it, like you did earlier, who's on what medication, instead of trying to read the data and trying to invent, it's going to understand that, okay, in the prompt, the name of a specific patient was mentioned, right? And since there's already an API that exists that can serve, like the patient information, call that, and then get the results, and then inspect that single row that came back as the result, and then based on that, give the answer of whether or not the specific person is on that med or not. So that can be done that way, even without having like a vector database and do all this processing.
Yeah, that's right. So I've seen literature recently that are even using graph databases instead of the vector, or they use it side by side. So, for example, your graph database will house your corporate hierarchy, your department hierarchy and all that. So, based on the question that is coming in, when it hits the vector database, and then based on the terms in the question, it may look up specific department or business unit information in the graph database and pull that information as well, together with the vector, the retrieval result from the vector, and then the query template, sets the template and pushes it to the LLM. So yeah, there are a lot of different concepts that can be incorporated here. So I agree with that.
Yeah.
And the agent is pretty cool because you can specify a lot of tools to the LLM.
Yep.
And then based on the query, the LLM will know. So basically observe the input, and then determine which tool to call to accomplish the task.
Right.
Yeah, so it's pretty neat.
Yeah, maybe I can say it another way if it, if my explanation was a bit too complex. So let's imagine that, for example, I speak English. I don't speak, let's say German, right? But I have a German dictionary. One way to process that dictionary could be like using the embeddings and all the vector databases, or as an LLM, I just need to be able to flip through the pages, so that if you ask me, how do you say this word in German, even though I don't speak German, I have a tool which is the dictionary available to me. I can go through the index, find the word that I know in English, and then just look up the corresponding the equivalent in German, and then return that as an answer. It's pretty much like that.
Yeah.
So it can be like any number of tools. It can be a tool that can look up the org diagram into a graph database. It can be an API. It can be anything.
So that's a powerful extension of the LLM, right?
Yeah.
Because you can build an LLM to handle so few things, so many things, but you cannot do all. But using the agents, you can really extend how the the functionality of the LLM to use all these tools. And
Yeah.
Any questions?
Nope. don't see anything.
Okay. Ben, did you post the Discord?
Yeah.
Ben? Okay.
On the Discord. Yeah,
All the links are posted. Ben posted everything.
I can share the link again for Discord. Okay. Okay, I just posted it.
Okay. Any more questions?
Yeah, any thoughts? Anything?
Comments?
Related to the presentation or not? Like anything?
Yeah, I think most of the questions were asked along the way. So,
Yeah.
For me, just want to say thank you as usual. So, great presentation.
you're welcome.
Are you next?
Not yet.
I'm teasing. Yeah, thanks, Kofi, for taking us through RAG with LangChain. For sure, that was a nice talk. Lots of engaging questions. So, yeah, appreciate your time.
Thank you very much.
Yeah.
I understood many things, trust me.
Yeah, no, definitely. He simplified a lot of concepts that I was having a hard time understanding. It was
Yeah.
you really simplified that for me. Yeah.
Definitely.
Yep.
Okay, thank you.
Thank you all. Have a good weekend.
Okay, bye-bye.
Thank you.
Bye.
Bye.
Bye-bye.